Today we're going to talk about pedigrees, and the goal of this video is to explain how to create and interpret a pedigree. So first, what is a pedigree? A pedigree is a chart that shows inheritance patterns over a number of generations. And pedigrees are often used to study the inheritance of genetic disorders. The image on the right here is an example of what a pedigree looks like. Now, a pedigree is made up of symbols, and I want to explain what each of these symbols means. When you see a circle, that represents a female, and if the circle is not shaded in, then that is a normal female. When you see a square, that represents a male, and if the square is not shaded in, that is a normal male. If you see a circle that is filled in, then that represents an affected female. This is somebody, a female who has the trait that you're tracking through this pedigree. If you see a square that's filled in, that is a male that is affected, or a male that has the trait. Now, when you see a dot in the center of either a circle or a square, that represents an individual who is a carrier. This individual would be heterozygous. They would have one of each allele here. If you see this diamond, the sex is unknown. It's unknown whether the individual was male or female. If you see this black small circle, that means the individual died in infancy. Whenever you see a horizontal line connecting a male and a female, so like this is a horizontal line connecting a male and a female, that represents that they have produced children together. That's a couple who's produced children together. And when you follow the line down, this couple had a son right here. They also had a girl right here. Wherever the lines connect, they had a girl here. But see this symbol right here where it goes down and branches, that would represent, in this case, identical twins. And these were identical twin boys. If you see, on the other hand, children like this, where it's one boy, one girl, these are non-identical twins. And you'll notice on the left, the generations are listed. So there are lines of individuals. So this is the first generation at the top. In the middle here is the second generation. And then at the bottom is the third generation. And notice every individual is also numbered. And they're numbered in birth order. So whoever's the oldest goes on the left and the youngest goes on the right. Okay, now specific individuals are labeled as the generation number, then the birth number. So for example, if I said point to the individual that's generation 3, individual 4, here's generation 3, individual 4 would be right here. I'm talking about this individual. All right, so let's practice interpreting a pedigree now. How many males are in this pedigree? So males are represented as squares. I see 7 squares. 1, 2, 3, 4, 5, 6, 7. How many females are in the pedigree? There's 6. You can count 6 circles here. How many generations are in the pedigree? There would be 3. 1, 2, 3 generations. How many children did couple 2, 5 and 2, 6 have? So go to generation 2. Here's person 5 and 6. Follow the line down. They had twins. So those are 2 children. And then here's child number 3, child number 4, child number 5. They had 5 children together, but notice one of them died in infancy. So they had 5 children total, but one died in infancy. A couple more practice questions here. How many males have the trait that's being tracked? So these will be males that are shaded in. There are 2. 1, 2. How many females have the trait that's being tracked? There are 2 females, 2 circles that are shaded in. 1, 2. How many individuals are heterozygous for the trait being tracked, and who is it? So heterozygous individuals have a dot in the center. That'd be 1 individual that's heterozygous, and it's this one, generation 1, person 2. To finish up, we're now going to use a pedigree to determine genotypes of individuals. So when you are using a pedigree like this, you need to know a couple things. You need to know the pattern of inheritance. Sometimes you can figure it out just from what's filled in, whether circles or squares are filled in, and so on. But if you're told what the pattern of inheritance is, and you're told if the trait is, if the allele is dominant or recessive that's being tracked, then you can figure out genotypes of individuals. So for the examples we're about to look at, the pattern of inheritance is going to be complete dominance. And the trait that's being tracked in this case, on this slide, is a dominant trait. So that means that everyone that's shaded in has a dominant allele. Everyone that is not shaded in would have recessive alleles. Okay, so when you're figuring out the genotype, the letters to assign to each individual, every individual that's shaded in, if the trait's dominant, every individual that's shaded in, they're going to have at least 1 capital letter. So notice, for everybody that's shaded in with black, I've given them at least a capital A. Now, you may wonder, well, how did you figure out the other letters? For that, you're going to have to look at the offspring of the couple or the parents of that individual. And I'm going to show you in just a second how that works. But to everyone that was shaded in, I gave at least 1 capital letter. That's where you start. To every individual that's not shaded, you give 2 lowercase letters in their genotype. So everybody that was not shaded in, they have 2 little a's. Now, look at this first couple. They have a big A. This person has a big A because they're shaded in. But how did I figure out that this person has a little a? Well, I look at their child. So this couple had a child right here, and this child had 2 little a's. Well, one of those little a's came from this parent, and the other little a came from that parent. So that's why I put a little a here and a little a here. And I've drawn the arrows in to show you how I figured out the other letters as well. But notice in this case with these 2 individuals, you can't figure out what letters they got, what their second letter is, because a big A came from one of these parents, but the other parent could have given that child a big A or a little a. We don't know. We can't look at their offspring and tell. So that's why I had to put a question mark for them. So this is how you would go about filling in the genotype when the trait that's being tracked is dominant. What about if the trait that's being tracked is recessive? If it's recessive, then every individual that's shaded in gets 2 lowercase letters, and individuals that are not shaded in get at least 1 capital letter. And similar to before, in this case, everybody that's shaded in has the recessive trait. Recessive traits get lowercase letters, so that's why everybody here has lowercase letters. Everybody that's not shaded in has at least 1 capital letter, and just as before, we look at their offspring or their parents to figure out if they have what their second letter is.